Okay, so yesterday we talked about random variables, what they are, and we talked about how to calculate expected value and deviation and how to interpret this, right? We talked about discrete random variables. Now, today I'm going to show you how to do this math, but on the calculator, okay? Because the calculator will do it. Okay. Just leave it outside. Just leave it on the desk there. Yeah. Um, so let's go to your calculator. So we're going to calculate the exact same number. Difference is it is going to be calculated on the calculator, not by hand. Okay, so first thing you're going to do is we're going to go back. We need to put the table in. That's the first thing we need to do. So anytime we need to put a table in, those are lists. So we need to go to the list. We haven't done this in a while, but we've done it lots before. We haven't done it for like the last 2 chapters, but we've done it many, many times before. Okay, so I need 2 blank lists. Okay. Okay. One of the lists, you're going to put the list, it's going to look exactly like the table you have here. The table we have here for the Buffalo Wild Wings promotion, X is going to go first. The probabilities are going to go second, side by side. So the first one is 5, comma, not comma, but 5.890. So 5.890. The next one is 15. .098. The next one is 25.010. Last one is 100. 0.002. Okay, so now we have the table. Table just looks vertical, but it's the same table that you guys had here. Okay, that's the first step. Put them in. Every random variable needs to have a probability. So you can't, they have to be the same. So 5 has to go with 0.89. 15 has to go with 0.098. 25 has to go with 0.010. 100 has to go with 0.002. Okay, that's the first thing. Second thing is you're going to go to stats. Most of the time when we calculate things in this class, you're going to go to statistics. Then we're going to go to calc because we want to calculate something. Okay. We're going to hit 1 var stats. 1 var stats. Okay. My list. The list it's talking about are your random variables. So wherever your random variables are, that's the list you're going to have. I have them in L1, so I'm going to put L1. Frequency list. Frequency list. We haven't used frequency list. Make sure you're looking up here. Don't look on your calculator because then you'll lose track of where you are and then you won't know what you're doing. So watch me do it first and then you can do it on your own. Okay? Frequency list. Frequency list we haven't used. We've just kept it blank, right? Because we've only had 1 list. We haven't had 2 lists. But now I have random variables and I have probabilities with them. Probabilities are frequency lists. Remember we talked about that yesterday? Relative frequencies are the same thing as probabilities. Relative frequency means what percent of the time are they going to happen? That's the same thing as probabilities. So where is that list? This is the only chapter where we're going to actually fill that in. So I'm going to put L2 because that's where mine is. Whatever list your probabilities are at, this is the only time we're going to fill in this list. Every other chapter, we're going to leave frequency list blank. It's what we've been doing the whole semester. But now we have a frequency list. Okay? So now you're going to hit enter, calculate. There you go. Top one, 6.37, the average. If you go a little bit further, standard deviation, 5.475. We rounded a little differently, 5.48, but it's pretty close. Okay. Now that I showed you that, how does that change how I answer a question? It does not change anything at all. If you were to have this question on a free response, multiple choice is different. Multiple choice, you just need to show enough work to get to your answer. Okay. Free response, if I don't see this work here, you get 1 point for the answer, and then you miss the other 2 or 3 points. Okay. Because I need to see how you got it. I don't want to know. I don't want to guess. How did they get 6.37 on your quiz? Some of you missed points because you got an answer, and I'm like, how in the world did you get that? Either you didn't show me, or I couldn't read it because it was so messy. And I'm like, how did you get that? You don't want your reader asking that question. You don't want your reader saying, how did they get that answer, right? Because it's either wrong or there's not sufficient work to show. Okay, so I would do this problem the same exact way I did this problem. No difference. The only difference is I would just use a calculator to calculate it. Same thing here. Okay? Because I know I'm going to get people who do this. I know I'm going to get people who do this because it happens every year. Who do this. For this question here, they get on the test and they do this question here and they say, done. And they move on to the next one. I give them 1 point because they got the right answer, but then they lose the other 2 points because I don't know how they got there. I'm like, right? I have to see how you got there. Okay? So that's why you need that. Now you could probably cut this short. You don't need all of this. You could just write, you don't need to show all of this since we're not calculating stuff. You don't need this part here. Right? That part's okay. You don't need that middle stuff since we didn't calculate it each, but I need to see how you got that number. Okay? That is full credit. All of that stuff missing like before, you'll get credit, but you won't get full credit. Okay? And I think you want all the points instead of just 1 point, right? 1 out of 3 is 33%. That's not very good. Okay? So that's what I'm saying. So this helps on multiple choice questions because if they asked you, what is the standard deviation of this table here? Then you don't need to show work. You just need to type it in your calculator, punch in your calculator, boom, right? But if it's a free response question, I need to see this work here. Okay? And then you can punch it into the calculator and say, that's how I got it. Okay, so it saves you some time, but just be careful with that. All right. Okay, so let's do, there's one problem on the back. There's one problem on the back, but I want you to add another problem because there's one problem that you're going to see that I didn't get a chance to put on there. So add this problem to the bottom. You got a whole page. Add this problem somewhere. Number 5. Your number 5 is different. Add it to the bottom somewhere. The daily lottery costs $1 to play. You pick a 3-digit number. If you win $500. Find the mean and standard deviation of the lottery. Should you play? One of the questions they're going to ask you are games. They're going to say, what do I expect to win? Right? What do I expect to win if I play this game? Okay, so I'll let you guys write it down. And then we're going to calculate. We're going to find the mean and standard deviation. And then we're going to answer the question, should I play the game? Should I play the game? This one's number 5. The next one, the one you have, is number 6. So just change the numbering on yours. So anytime you're finding the mean or standard deviation of something with probability, you need a table, right? We had a table, the table you just put in your calculator. That was the table they gave us. Sometimes they'll give you a table, sometimes they won't give you a table. So if they don't give you a table, you need a table. So that's the first thing we got to do, make a table. Okay. So there's three things we need. We need to find the mean, standard deviation, and then answer the question. We have to actually, should I play? Should you play? Why or why not? Yeah, you should play. Why? No, it's not worth my time. Why not? Okay. So the first thing we got to do is make a table. That's what I'm going to do first. I'm going to make a table. Okay. What goes on the left side of the table? No, not the lottery. Close. You're close. Well, here, there's a 3-digit numbers. How many 3-digit numbers are there? Yeah, I don't want to have to list those. So let's not list numbers. Let's pick some other thing I could list. The what? The day? No. So, what's that? No, not like that. You guys are close, but see, so here we go. What goes on the left? Every time, what goes on the X? Okay, so what goes there? What are the random variables? What's another word for random variables? Not for this problem, just in general. Okay, but what are they? What are random variables?
The countable number of possible values.
What does that mean? I wrote that down. I know what it means, but tell me what it means. Looking for two words. There you go. Sample space. What is a sample space? Everything that can happen, right? Everything that can happen. Well, we just said there's 999 different numbers I could get. I don't want to have to write those down. So instead of numbers, what other kind of outcomes could I do instead?
You can the winner lose.
Close. You're getting close. What does that mean to win?
Or getting that one number that'll get you 500. So 1 out of 999.
There we go. Money. How much money you can win. What are the outcomes in terms of money, right? Well, if I play this game, what can happen?
You either get 500
Okay, so I can win $500.
or you can win $0.
Or I can win $0. Is there anything else that could happen? How do I lose $1? So if I lose $1, okay, so how do I win $0? These are both the same thing, right? Which one do I use? It doesn't matter. It doesn't matter. Some people, so here, but it does matter. So let me explain what it matters. If you use 0, you're using just winnings, right? I could win 500 or I can win 0. If you change it to net gain means after you recoup your losses, right? If it's net gain, then you can do this, right? But then 500 would be true. It would be 499, right? So then you got to change that to 499. So it doesn't matter which one you use, but you have to be consistent. You can't put -1 and 500, or you can't put 499 and 0, right? You have to stay consistent. You have to stay consistent. So if you're going to go net gain means after I pay, how much money do it? Because if you pay $1 and you win 500, you're not technically winning $500, right? It's 499. Or you could think of winnings. I keep it simple. Think of winnings. Just think of winnings. Just think of winnings. So let's just go 0 and 500. You could do 4.99 and negative $1. It works. You'll get the same answer. I'll show you. I'll show you afterwards. Okay. Okay, so now is there anything else that could happen? Can I win $25? Can I win $1? Can I win $300? Can I win $1,000? Can I win? Is there anything else that could happen? Okay, then that's all. That's the sample space of. That's the sample space of winnings. That's the sample space of winnings. Okay. Now we have to go with probabilities. What is the probability I win $500? 1 out of how much?
9.
There we go. What's the probability I win 0? There you go. Everything else, right? If these are the only two things that can happen, then they have to equal 999 out of 999, which is 1, right? They have to. Okay. There's our table. How do I find the mean of that table? The answer is in your notes. You use the formula. Yeah, you use the formula. The formula we used yesterday, it's the same formula you're going to use today because we're finding the mean or the expected value of a table, right? So we take the random variable and multiply it times the probability of that happening. Okay, so $500 times 1 over 999 plus $0 times 998 over 999. And that's the only two things that could happen. This one's not hard. This is another reason why 0 is a good thing to do, because this will just go away. So this one you really don't even need to use the calculator besides just multiplying, right? It's just going to be 500 over 999, which is 0.5 something. Very close to 0.5, 0.50 something probably. 0, 1. Oops, not that. Yeah, if I go 3 digits, the last digit will be a 1. Okay, that's expected value. Okay, standard deviation. Standard deviation. So standard deviation, we have a formula as well. That one said, take the random variable, subtract it from the mean. Take the random variable, subtract it from the mean. Okay, so the random variable is $500. Subtract it from the mean, which was this guy here. Square it, and then multiply it times the probability. Do it one more time. 0 minus 0.501 squared times the probability, which is almost 1 whole. Almost 1 whole. 998 over 999. And then we take square root, right? So this one, it might be a little bit easier to do the table on your calculator, right? This is the work I need to see for both. This is the work I need to see. Once you do this, then you can go to the calculator. Make a new table. I'm going to erase my old one. 500. 0. 1 divided by 999. 998 divided by 999. Stat. Calc. 1 var stats. My list is in L1. My frequency list, my probabilities are in L2. Calculate. Top one we already got. Now we need the standard deviation. Standard deviation's 15.811. What units are each of these guys? What units are each of these guys going to be?
$.
Yeah, money, yeah. Yeah, dollars. Okay. Okay, so we go back. Okay, so I answered 2 parts. Got the mean, got the standard deviation. Good, I got the 2 out of the 3. So the third point comes from, should I play or not? It's a yes or no answer. But you also have to say why. So we're either going to say, yes, I would play because. No, I would not play because. How should we make our decision? What's our decision going to be based on, I should say?
Can it be on our odds of
No, not the odds of winning. That's not going to. Trust me. What was it? The $2 billion Powerball. The odds of winning, you have a better chance of being struck by lightning like 138 times in a row than winning the Powerball. But the line was around the corner, right? So if you tell people odds, they don't care. But if you refer to money, they do care. So how can we use money to say yes or no?
on average will win like 50 cents?
There you go. Now we're talking. If I were to play this game, how much money would I expect to walk away with? 50 cents. About 50 cents. That's good. I get 50 cents, right? I'll play the game a million times. That's $500,000. What's the downside?
You spend a buck to
Yeah, you're losing 50 cents every time, right? So you're winning 50 cents every time, but you're paying $1 to play, so really you're losing, right? So that's what we're going to explain. That's what people understand. Every time I play this game, I'm literally giving them 50 cents. That's what's happening, right? Now, could I win this game? Is it possible I could win this game? Yeah, it is possible. But in the long run, I'm going to end up paying them 50 cents for every time I play. Right? I might win once, but I'm not going to win very often. Maybe once every 1,000 times I'm going to win. Right? So that's what we're going to explain. Should I play? No, I should not. No, because for every dollar wagered, I expect to win 50 cents, thus losing 50 cents every time I play. Yeah, that's what people understand. People understand money. If you tell them money, right? Same thing with the lottery. Right? There's different things you can win. You could win $2 billion. You could win a couple $1,000,000. You could win $50,000. I could win $5, right? But those probabilities are so low, so low. The probability of winning $2 billion, I don't have enough room on my blackboard for the zeros. 0.000000000 on my whiteboard for that. There's so many zeros. It's just what's that? That's all they need to hear. That's all people need to hear. It could have been me, right? Could be me. Yeah, the lottery is one of the biggest wastes of money, but I don't mind it because a lot of like half of that money goes to schools, goes to the school system. So we make the schools, the each state has their own lottery, so like half of the money goes to schools, so which is good. I think it's good. But if you if you if you wager on the lottery based hoping to win, you have a better chance of swimming in the ocean 100 times and getting bitten by a shark every single time in a row. It's just not going to happen.
But it's like half is 50% chance you'll win.
What's that?
There's a 50% chance you'll win. Because you either win or lose if you buy a lot.
That's what people think. Yeah, that's what people think. Oh, it's a 50-50 shot, right? I win or lose 50-50, right? Here's my money. That's what people think. But like I said, I will never tell people not to play the lottery because I know it goes to the schools. It benefits all of us. But no, I'm not.
You're not much for
No,
gambling.
I'm not. The gambling period is just not a good way to make money. Just because the odds are against you. Every time you walk into a casino, you're already behind. You're already losing because they know that. That's how the casinos, how the casinos stay in business because sucker walks in every second. So will some people win money? Yeah, some people win money. I'll pay one person $100,000 a week because I know there's thousands of people that will come in and lose over, like lots of money, right? That's why they put people on bulletin boards. You drive down Shaw. Oh, this person won $100,000. This person won a new car. This person won this, right? What they don't show you is the thousands and thousands and thousands of people who lost lots, right? So yeah, that's what they don't show you. Okay.
I'll take my chance.
Well, yeah, some people are like, I'll take my chances. That's that's what you're that's right. Okay, so anyway, last thing, last question, we're done. I left this one for last. So this is number 6. It was number 5 on your paper. Okay, so this question is continuous. We've spent a lot of time doing discrete. Every 1, 2, 3, 4, 5 questions, examples number 1, 2, 3, 4, 5 were discrete. This one is continuous. The reason why I only gave you one of these problems is because it should sound familiar. These types of problems should sound familiar, especially these words right here. Normal distribution, a mean of 64, a standard deviation of this, right? We did this in chapter 2. This is chapter 2 stuff. So we don't spend a lot of time with continuous because you guys have already done that. Okay, so the question says the heights of young women can be modeled by a normal distribution. I can't make a table for this, right? If I had the heights of all young women, that list would be long because let's say someone's 5'5" and someone's 5'5". My wife is 5'3". Let's say there's someone else that's 5'3". They're not exactly the same height, right? If I broke it down even more, they're both 5. They both rounded to get to 5'3". Okay, so doesn't mean you're exactly the same height. So the number of um, random variables would be too long. It's not countable, right? It's not countable. Heights, weights, things like that are not countable. So we use standard or normal distribution. Okay. So we're normal distribution. We have a mean of 64. We have a standard deviation of 2.7. The question says, suppose we choose a young woman at random. Let y equal her height. Find the probability that she's between 68 and 70 inches tall. So the first thing we got to do is draw the normal curve like we did in chapter 2. And we're going to do a lot more next semester. Okay, we're going to come back to this. Starting with chapter 7, we're coming back to this stuff here. We've kind of gone away from it, but we're going to come back to it. What goes in the middle? The mean, 64, right? 64 is the average for young women. I'm trying to find the probability of what? There you go, right? So that's what I'm going to shade. Probability between 68 So let's say 68's right about there and 70's right about there. That's what I'm trying to find. I'm trying to find that decimal. Okay. So how do I do that? What did I do? What was the next step that I did? Z-score. I need to find Z-score, right? So the Z-score, let me make this a little smaller or move this a little bit over here. Z-score, the formula is still the same. Z-score means the number minus the mean divided by the standard deviation. I have two numbers. I have 68 and 70. So I got to do one at a time. So I'll do 68 first. 68 minus 64 divided by 2.7. Get 1.48. That's the Z-score for 68. What is the Z-score? Z-score is what? Huh? It's a standard deviation, yeah. Okay, so I go to my table. Table that looks like this. We haven't used for a while either. And I look up my Z-score. 1.48. 1.48, which is 0.9306. 0.9306. Okay. So is that my answer? No. That is the area that is yellow. That's the yellow area. That is the yellow area, 0.9306. It's not quite what I want. I want the green. So now I'm going to do 70. 70 minus 68 divided by 2.7. That's 68, 64. The mean is 64. Yep, 2.22. So then I go to my table and I find that guy. .9868. So is that my answer? 0.9868? No, that is the yellow and the green. So I have the yellow, and the green. What do I do? Subtract them. Good. So it's going to be 0.969868 minus the yellow. And that'll give me the green. Oops, nope. Okay. That is my probability, proportion, right? So now, last thing I have to do is interpret it, make sense of it. Okay. So the probability that a young woman is 68 to 70 inches tall is 0.0562. 68 inches, what is 68? 5'8"? 5'8" to 5'10"? Okay. For a young woman, that's considered tall. So there's not very many of them. About 5% of every woman. About 5 or 6 out of every 100 that you see will be that tall. That's what it's saying. Okay. All right. Okay, so last thing I'm going to do, give you about 20 minutes to give you a chance to start on that. It's not due till Tuesday, or sorry, Monday. It's not due till Monday, but I won't see you guys tomorrow, okay, because we're days off. And then Monday it's due, okay? So if you have questions, today would be a good day to go through. So even if you don't get to a lot of them, it'd be a good idea to read them. If you understand them and you know what to do, then go on to the next one so that if you have questions, we